URScript is the text language built into every universal robot's arm, and it is the friendliest robot language to learn first. The syntax is close to Python. The core is small, and it has the biggest beginner community of any robot language. This is URScript from zero. The 3 move commands, the gripper, tool setup, waypoints, and a first pick in place you can run free in a browser. No urrobot, no license. By the end, you will have written a real URScript program. First, what URScript actually is. URScript is the text-based language built into every universal robot's controller. The UR3, the UR5E, the UR10E, they all run it. Here is the key idea. When you build a program on the Teach pendant with PolyScope, the graphical interface, the controller compiles that down to URScript under the hood. So URScript is what the robot actually runs. PolyScope is just a front end for it. Learn URScript and you understand the real language, not a picture of it. And because the syntax is close to Python with variables, if and while logic and functions, it reads almost like plain code. The heart of URScript is 3 move commands. The first is movej, spelled M-O-V-E-J. It moves in joint space. Each joint rotates from its current angle to its target angle. That is fast and efficient, but the tool follows a curved path. Use movej for free air moves between stations. The second is movel, spelled M-O-V-E-L. It moves the tool in a straight Cartesian line at a controlled speed. Use movel when the tool path matters. Approaching a part, inserting, following an edge. The third is movep. It moves at a constant tool speed with circular blends for process paths like gluing or dispensing. Each move takes an acceleration argument, A, and a velocity argument, V, that shape how fast it accelerates and travels. Now the gripper. This is where a program starts doing real work. The command is set_digital_out. It takes 2 arguments, an output number and true or false. Set output 0 to true to close the gripper. Set it to false to open it. To read a sensor, you use get_digital_in. Give an input number and it returns true or false. For example, is a part present? So picking something up is just 3 steps. Move to the part. Set the digital output to close the gripper. Then lift. 3 lines. That is a pick. The whole thing is that simple once you have a moves. Before the moves run cleanly, you set up the tool. 2 commands. The first is set_TCP. TCP stands for tool center point. It tells the robot where the working tip of the tool is relative to the wrist flange. Set it right, and a linear move keeps the tool tip on a straight line, not the wrist. The second is set_payload. It tells the robot the mass of the tool, plus whatever part is in the gripper. This matters for 2 reasons. The arm moves more accurately when it knows the weight it is carrying. And on a collaborative robot, the force monitoring that triggers a protective stop depends on an accurate payload. Get the payload wrong, and the safety system gets confused. So you always set it. Next, waypoints and blends. A waypoint is just a top pose, a position you want the arm to reach. By default, the arm stops fully at every waypoint. Stop, start, stop, start. That is slow and jerky. So you add a blend radius. A blend radius rounds a corner. The arm flows through the waypoint without fully stopping, like a car taking a racing line through a bend. A bigger blend is smoother and faster, but the path cuts the corner more. So the blend is a trade-off you tune for each move. Chaining waypoints with blends is the difference between a program that works and a program that runs a full shift at speed. Now, put it together into a first pick in place. You set the TCP and the payload at the top. You move J to a safe home pose. You move L straight down onto the part. You set the digital output to true to close the gripper. You sleep for a fraction of a second to let the gripper settle. You move L straight up to lift. You move L across to the place position. You set the digital output to false to release. And you move J back home. That is a complete pick-and-place cycle. Those are the exact commands that run on a real UR controller. Nothing simplified. Write that program, and you have programmed a robot. And you can write and run that exact program free in your browser. Open the URScript tutorial and reference at plcsimulationsoftware.com/learn-URScript. It has every command, an example program, and a walkthrough of how a line of URScript becomes motion. Then open the simulator at plcsimulationsoftware.com/robot-play and run your URScript on a simulated U, or ARM under real physics. It is a real kinematics browser sim running real URScript, not a vendor emulator. So the language transfers straight to a real UR and PolyScope. The next video maps robot programming for PLC programmers. If you know ladder logic, this one is for you. Subscribe, new video every Tuesday. See you in the next one.